Okay, so let's start now. Good afternoon, everyone. My name is Meherzad Pantke, and I'll be the presenter for today's webinar. So let me start off by giving everyone an idea of who we are at CloudThat. CloudThat Technologies is a training and consulting company. We were founded in 2012. We have trained over 7,000 professionals in the last 5 years. We provide training and consulting services in cloud, big data, and IoT domains. We at CloudThat have a dynamic team of certified professionals. We focus on quickly empowering IT professionals and organizations to leverage cloud and big data. And we have a huge, robust consulting division that complements our trainings. And we have a global presence in consulting and training market. So now let me give everyone a brief idea of who our speaker for the day is, Mr. Shivam Sharma. Mr. Shivam works as a subject matter expert at CloudThat Technologies. He has been involved in various large and complex projects with global clients. He has experience in blockchain, machine learning, and Microsoft infrastructure technology stack, including Azure Stack, Office 365, EMS, Link, Exchange, System Center, Windows Server, and designing Active Directory. Having core training and consulting experience, he is passionate about technology and is involved in delivering trainings to corporates and individuals on cutting-edge technologies. So now let me hand over the proceedings to our speaker for the day, Mr. Shivam Sharma. Shivam, please.
Thank you, Meherzad. Thanks for the lovely introduction. And guys, in case if you're facing any problem with the audio, just let us know, right? You can simply type that on the chat. In case there is starting in the voice or something else, you can also let us know. And throughout this webinar, in case you face any, you have any doubts, any question, anything, right? So simply feel free to type it down. I'll answer all the questions in the end of the session. So quickly, okay. Okay, so let me know if you're audible or not, right? If I'm audible or not. So, okay. So coming over the agenda of this webinar, so we'll check out that what is blockchain, right? How it all started, what's the origin of blockchain, what is all the hype about. See, now blockchain is more like a new revolution which is coming. Some people call it a revolution, some portray it as the most disruptive technology that will change the business, all the businesses, how they're running and all that, right? And even the Gartner has reported that blockchain is one of the most emerging technology, and a lot of people are talking about it. So this is something that you cannot simply ignore. It's going to be as big as internet itself, as big as World Wide Web. Now, blockchain has this huge untapped potential right now, a huge market. So in case you're entrepreneurs, in case you have some ideas of your own, you can simply use blockchain itself to launch your ideas. Now, the Dubai government itself has started using blockchain. They have moved their IT data onto a blockchain. So people are, the world itself is moving to this new revolution. It's better to ride the tide or sort of being left behind, right? There's always space on the top. So we all keep an eye on the Bitcoin prices, how they are touching the sky. Microsoft, IBM, and other MNC giants, they have already started taking measures to sort of become emerging market leaders. So blockchain has created this tremendous, enormous technological excitement, right? So it's very important for us to understand it, how it all started, what is the origin, what is blockchain, right? So what's a blocks, how it makes a chain, how the consensus is made, how it works, the type of blockchains, industry use cases. So we're going to discuss all these throughout the course of this webinar. So in case you have any questions, just simply type that down, right? So now I'm quickly moving on to the presentation. The origin of blockchain started with the Bitcoins. Now Bitcoins are the digital cryptocurrencies. They came into existence in 2008. They were created by Satoshi Nakamoto. So back in those days, 2011 around, one Bitcoin on $1, only $1. And there was a point in time when the Bitcoin prices went down to 30 cents. And if you check out the prices today, yesterday I checked this price and it was about 7,000 in 2017. So it's an enormous increase in the prices of Bitcoins. So in case you're thinking of going back in time and purchasing more of Bitcoin, uh, don't be disheartened. Bitcoin is just one implementation of blockchain. Bitcoin is more like your digital cryptocurrency, your digital cash. So just like in a normal bank transaction, you can see your account balance, right? So you can, in a Bitcoin blockchain, you can also check out your wallet balance. We'll talk about all this. Now, when you talk about Bitcoin, this digital cash, the digital coins, cryptocurrency, there are more cryptocurrencies there in the market right now. So there are around 1,000, 1,000, 117 to be accurate. So some of the largest big blockchain networks contain Bitcoin, Ethereum, Bitcoin Cash, Ripple. Just to let you know that they runs on a connection of computers, a peer-to-peer network of computers. We'll talk about this through in some later slides, right? And everything is decentralized. When you talk about Bitcoin, there is no central regulating authority. There is no bank. There is no regulator sitting over top of bank and financing everything. There is no one who's sort of, let's say, demonetize your currency. And so that is not possible, right? Everything is decentralized. Everything runs on a peer-to-peer network computers. Anyone can join. Anyone can do a transaction. By design of the system itself, it eliminates the middleman. It eliminates any regulatory authority which is required to maintain your transactions, to create trust and let's say, right? So by design itself, that's possible. So before we sort of start into elimination of middlemen, let's check out first that why middlemen are required, why middlemen are important in a transaction, how they establish trust and how they make the trade fair, right? So middlemen, you can talk, let's say you are having a transaction, you are doing a trade. So generally in a trade there are two parties, right? So whenever you're doing a trade and there is a trusted middle party, a middleman, so they can act as a broker between the seller and the consumer, right? This is one of the way in which you can sort of middleman can help you out. The second is by establishing trust between the two parties. They ensure that the fair trade is fair, that whatever you are paying for you get. Transactions, they validate the transactions, everything is centralized, so you know where you have to go and whom to ask in case something goes wrong, right? So you have so some of the middlemen you can so I'll just simply have mentioned two of them here. So maybe some banks, some title companies, insurance companies, some companies who are holding your mortgages. So these different type of companies, they can act as middlemen, right? So this is, I'm just leaving for your imagination to see in which transaction which party is acting as a middleman. Now, one of the very key benefits of middleman is that they maintain the records and ledgers, right? So just like you have bank transactions, right? So bank maintains a account record that, okay, so let's say 100 people have opened the account. So what's the balance in their accounts, in they're doing some transactions. So how the transaction looks like, right? So this is your the bank, on the right hand side you can see there's a bank, right? On the left hand side you can see there is a record. It's called as a ledger. So if you simply check it, you can see that on the first transaction, the first record 01, you have the $100. Then there was a transaction between account number 1 and account number 2. So that's like $100 transaction. So account number 1, it's now reduced to 900, is increased to 600, and there is some third person whose account is there. So this is one of the one of the usage of having a trusted third party, that they can establish, they can hold these records, these ledgers in between whenever there is a transaction going on. Similarly, just check it out. So here is a typical ledger, a record of ownership. So on the right hand side you can see that there is a property. So some record, some bookkeeping, some balance. A record of this will look something like the property was owned by owner number 1, and then the owner 1 has sold this property to owner number 2, and the third record is the owner 2 has sold this property to owner number 3. Then currently the current owner is owner 3. So this was a typical record, a very simplified version of a record of a property, right? So let us check out that how it is very important, like what's the importance of middlemen. First, we'll check out what's the importance of middlemen. Then we'll check out how blockchain can sort of do the same thing which middlemen are doing, right? So see, in if there is a transaction, middlemen are very much required to establish trust. But however, if something is can be replaced by the system itself, then that's also something to be thought of, right? So just check out this first case. Here, there is no middleman in this transaction. So you can see there is a person on the left hand side is trying to purchase this property from the person on the right hand side. So there is no middleman, right? So this person is asking, are you the owner? So the person is simply saying, yes, I'm the owner, right? So if you want to relate the to having no middleman is more like you are issuing check on a piece of paper, right? So whenever you have an account in the bank, they provide you with checkbook. So in case you have to give some money to someone, you can always write a check to the said person. The person will go to the bank and get the money out of it, right? However, just imagine if there is no bank and you are writing a check on a piece of paper, right? So you have to trust the other party. You have to have the gut feeling, okay, so if he has written this check on a piece of paper, of money he's promised me, so he might pay me, he might not pay me. So there is a lot of mistrust in between. So similarly, in this case, there is a owner and the person is trying to purchase the house. So he's simply asking one person, okay, so are you the owner of this property or not? So the person is saying yes. So just there is no proof of it because there is no middleman, right? So middleman, having no middleman, it generates that trust gap. So there is a gap between the first party and the second party, and they all have to trust each other on gut feeling. So do you have any proof of that this property belongs to you? So the guy says, okay, so check the records. So this book has been maintained by this person himself, right? So he's producing some records from his own, from himself, right? So there is no one to validate these records. So this is the same record. You can see property was belonged to owner one, property then belonged to owner number. There was a transaction from owner one to owner two. Then there was a transaction from owner two to owner three, and then the property finally belonged to owner three, right? So this was a normal transaction, which was normal record, normal book of this property. However, the problem with having no middleman is that anyone can simply delete the records. They can forge it. They can put in more records. They can change it. They can say, okay, the property belongs to me. So now you can see that the property owner is owner number 4. So this person might be he might be a con artist, right? So he has sort of removed those records and has introduced new records. So this is what happened when there is no middleman. And if you check out news, you get these type of news every day. Okay, so people they are doing fraud. They have doctored the documents, and even big companies which you can think of, they have doctored their documents and sort of have done huge big frauds, right? So this is one of the downfall, the south side of having no middleman. So it's quite obvious that if there is a middleman, so the middleman establish trust. So in the same transaction, if the property was this ledger was maintained by the middleman, right, the trusted third party, which both of them can trust, maybe some government authority, maybe some any insurance company, or maybe some other central regulator, then this transaction have more trust, right? So this person can believe, okay, so if the trusted third party is saying that, okay, so this property belonged to this guy, then it might be belonging to this guy, right? So the transaction can happen, he can pay it, and he can get let's say money out of it, right? This property belongs to him, and there will be a new transaction that the new property owner is, maybe this is owner number 5. So this is the, let's say, the benefits of having middlemen. And but there is as you already sort of know, that it's human nature that whenever you get a lot of power, whenever you get a lot of centralization of power, then sort of corruption evolves there, right? So if you simply check out over the internet, you can find numerous examples of this, that some trusted third parties, they were involved with the party to have committed frauds. We all know about the AAA security mortgage bonds, which were there into US, right, which caused the recession, how they failed, how everything failed, security. So even the regulators were mixed, sort of involved. They had the same, they were like in the same pot with the companies who were sort of doing these frauds. So whenever there is a third party, It's called as centralization. All the transactions, all the records, all the books are kept by that single trust third party, right? You have to trust them. So they also charge you the processing fee, and they have a very hierarchical structure. So there are layers and layers and layers of management, and their processes are very complex. If you check out the bank processes these days, their terminology, their concepts, their the words which they use, they are so complex, and you simply cannot relate to them, right? And you don't even know that whether they are on a purpose making things so complex, why there is zero to less transparency. So sometimes it happens that you purchase you in some let's say your money is with the bank and you have no idea where they are investing it, right? So this type of zero to less transparency happens when there is a third party, because everything is centralized. They have all the rights, all the control over on that data, right? So they will be decision bottlenecks, and they are the sources of corruption. So you have seen both the downfalls and the positive points of having a trusted third party, right? And the alteration of records still happens. So that's totally possible that the trusted third party, whoever you are trusting, they also can alter the records. Generally, in our financial system, we have regulators sitting over the banks. So the hierarchy, so you make a transaction with the banks, and we have regulators who also sort of check out the banks that they are not doing some, let's say, some malicious activity or something like that. So they are not doing any sort of corruption. They are not altering the records. The transparency is maintained. So all this thing it still happens when there is a trusted third party. So you can see that there is we have we have seen both sides of the coin. Now just to check out one more thing, that what is the solution to this, right? So in case you see that the first let's say having no middleman, having middleman, both you have seen sort of, right? So if you can change that entire equation, if you can change the entire system, right? If the system itself is trustable, if the output of the system itself is trustable, see, you do not need a middle party to do a trade, right? Middle party is only required when you have to create this trust. So let's say you are doing some transaction, and the system over which you are doing the transaction, that system itself creates the trust for you. So you can believe that, okay, if you have let's say send the money to someone, so he will receive it, right? And if that person has sent the money to you, you will also receive it. There is no double spending. It's not like that person has sent the same money to someone else and it's also he's sending it to you. So you can trust the entire system, right? So blockchain is that one system. It allows you to trust the output of the blockchain system without trusting any actors within it. So we are coming back to the fundamental question that we had since the starting, which the one of the objective of this webinar. Then what is blockchain, right? So we see that having a middle party it's great. Having no middle party, if you can some sort of replace it with a system that also is more like that will work, right? So let's check out that what is blockchain. So I'm again taking the leverage of explaining what is blockchain with the help of a transaction. So really, if you want to understand blockchain, you have to see that how it works. If you see how a blockchain works, you will understand what is a chain, what is a block, how it takes the transaction, how it all works, what's cryptocurrency, what is digital cash. So again, I'm simply explaining it with the help of an example. So here in this example, on the left hand side, you can see there is Jack, right? On the right hand side, that's Bob. So Jack is trying to send some coins to Bob, right? It can be digital coins. So we are talking about some coins. So if this was a normal transaction, normal bank transaction, so Jack and Bob both must be having their accounts in bank, and so you can relate it to a normal transaction. So if this was a bank transaction, then Jack must be having some wallet, and so wallet is more like his bank account. So if you do not have a bank account, you cannot send money, right? So you need to have a bank account. So you in blockchain system itself, you also have these wallets. These wallets are more like your bank accounts. So similarly, when you have a bank account, you have account number, as well as you have some secret keys, some passwords you need to get into your account, then you can transfer some funds around, right? So here also you have these two type of keys available. So one is called as a public key. The second is your private key. So public key is more like your account number, and your private key is more like your password. So you need to keep your public key or your private key very safe, because that's your password. You do not have to share it with other people. So in a normal bank transaction, what happens that, okay, so if Jack is trying to send Bob some money in a normal bank transaction, Jack need to have the account number of Bob. He needs to fill these details somewhere, then only he can do the transaction. So here also you need to have the public key of the other party, so you can have this transaction, you can send the money. So Jack will simply go to his wallet and put in the public key of Bob, and then that those 10 coins you were transacting, right? So that entire transaction he will click, and he will click on send, right? So I'm simply iterating again. So simply it's a wallet, two public keys, more like your address on the blockchain, your public keys address on the blockchain, your private keys, how you enter your wallet, right? So that's more like your password. So check this out. So whenever, so this is like back Bob and Jack's transaction, right? So Jack is trying to send some money to Bob. So we are coming back to that. So that transaction is broadcasted on the peer-to-peer network of computers that makes the blockchain network, right? So in the Bitcoin, so remember we talked about there is a P2P network of computers. So these computers, these servers, these nodes, they are nothing. You can use your laptops to help to act as a node. You just need to download the correct softwares, and then you can act as a node. However, your laptop might be having lesser compute power, so you might face some issue in that, right? So let's say these you can use your laptops, or however these can be servers, or in case you have a bigger infrastructure with you, you can also make some huge number of systems together, and they can act together and do this. Make this network Jack Bond. So whenever there is a broadcast, that transaction reach every node, right? Just check this out. So on the right hand side, you can see that there is a node, the same server. So you can see that there are two transactions, 01 transaction and 02 transaction. So maybe the 01 transaction is same as what is the Bob and Jack are doing right now. And 01 transaction, 02 transaction must be coming from some other person. So as you know that this is shared by a lot of people. So there is not only one transaction, there will be more than one transaction. Some other people must be doing their transaction, they will be sending some money and all that. So we are simply taking one example right now of digital cash. We'll talk about what's the entire capability of blockchain in the end, right? So just stay with me. So here you have two transactions. So they were the first transaction of your Jack and Bob. So that's what's relevant to us. So the nodes pick up that transaction. This server pick up the transaction. All the transactions which are there for some particular point of time, and they put it together. They call it as a block. So say they simply take the transactions, they package it together, they call it as a block. Now, in Bitcoin, per block, they are on an average, they are around 1400 to 2100 transactions per block, right? So here in the screen, I cannot put 1400 transaction, and I have simply representing it by two transactions. However, per block, you can have average of 1400 to let's say 2100. You can also have zero block, let's say zero transaction blocks, or maybe a block with one transaction. So the owner of the node, right? So if you're using your laptop for this, so owner of the node receives a transaction fee whenever there is a transaction done. So he receives a transaction fee, and there is an upper limit on the block size. So in Bitcoin, the upper limit is 1 MB. So this entire block will have the number of transactions which respect that upper limit of 1 MB. This is very important because you remember that we have a peer-to-peer network. So they will be talking to each other, right? We'll check it out. So this, just keep your eye on this, that the block size is very, you have to limit the block size. And you can, if your network is very powerful, you can have bigger block size as well. Right. So what we have done is Jack and Bob, they were having a transaction. They have broadcasted the transaction through their wallet on a P2P network of computers. That is your blockchain network. And there is a node. Node gathers the transaction together, makes a box out of it, and call this box as a block. Right. Just check this out. So different blocks nodes are there, right? It was a broadcast. So different nodes have picked up this different blocks. So which block to select, right? And just to remind you that it's a broadcast. So this is possible that the node number 1 and the node number 2 might have picked up different transactions, right? So it might be that the block number 1 is having 2 transactions, block number by some other node is having 3 or 4 transactions, or maybe 2100 transactions or something like that, right? So different block sizes can be there. So now let's see that which block will be selected and how this entire blockchain is formed. So the first thing is blocks are of different size, These nodes, you can also call them miners for this point in time. These nodes, these miners, they compete with each other to get their blocks selected and earn a reward. In case their block is selected, the owner of the node will earn a reward in whichever cryptocurrency is working on, right? So just check it out. How do they decide who wins? Like, so they all have their blocks, right? They want to win. So how do they decide who wins? They decide by solving this cryptographic puzzle. So all the nodes, they compete with each other. They get in a competition with each other that, okay, so I want to win, I want to win. So select my block so I can have this reward. I can sort of earn that reward. So just check this out. So that cryptographic puzzle, that's solved by using a hash function. Hash function, that is a mathematical function. If you put a data into a hash function, you get a hash value out of it, right? So your data is going in a hash function, and you get your value out of it. So just 2 points over here. The first point is that if that you do not change the data, right? If you do not change the data, the hash value will remain the same always, even in case. So here we are fixing two things: the hash function and the data, right? So your hash value will remain always same through. It doesn't matter on which computer you are trying to figure this hash value. It will remain the same throughout the world on any computer. So two things are important: same data and the hash function. In Bitcoin, the hash function is SHA-256. So you can see that that there is an example of a hash value written there. So it's a 256 bit long. So that's why that if there is a hash to SHA-256 and the data remains the same, so always the hash value will be the same throughout your network, throughout any node, throughout any computer, any mobile, anything, right? And hash values are one way. Hash values cannot be reverted, meaning if you want to understand with the example, if you're putting your fruits in a blender, right, you get a smoothie out of it. You simply are taking a different fruits, you put them in a blender, right, and you get smoothie out of it. So you cannot reverse this process. You cannot put the smoothie back into the blender and get the fruits out of it. Similarly, here also, if you put your data into the hash function and the hash value is figured out, you cannot reverse that process, right? Just keep this in mind, right? So and to let you know that mining, this entire process of mining, this is called as mining, it consumes electricity because this hash value is generated through hashing, right? So your computer, the resources of your computers are being utilized, and this target hash value is sort of calculated. So all the nodes all the nodes in your entire network, they get to compete with each other. They start fighting with each other to find this target hash value as quickly as possible, right? And they consume electricity, compute, and their resources to do so, right? So what we have so what we have over here is, so different nodes were sort of competing with each other. They were trying to find the target hash value first, right? So let's say the first one, any node, that node sort of have found that solution. He found the target hash value. So when you find, so it's now the problem. Next problem is that we need to select one block, right? So this node have already found that hash value which needs to be selected. His block is like needs to be selected. So what he does is he sort of broadcasts this solution, and the block which he having one or two transaction, maybe Jack's and Bob's transaction is there. So this node, it broadcasts the solution, the blocks which he have, and as well as a proof of work that he has consumed so much of electricity and everything. So he has sort of solved the cryptographic puzzle. So the proof of work is broadcasted over the network, that same peer-to-peer network. So here that block size is important to keep it small, right? So other miners validate the solution. They check out the target hash value. If that is okay, a consensus is made. They all accept that, okay, so that this person has done the proof of work. He has sort of figured out the right solution for the cryptographic puzzle. That's also very important, right solution of the cryptographic puzzle. So this node has sort of figured it out. It's okay. We have validated. There's a consensus made. Majority voting took place, and they accept the block. Right, so this block from this node is now accepted with those one or two transactions which were inside that block. The winning miner is the node, right? That winning miner, that node, and the owner, right? So if you are the owner of the node, you receives a reward in the digital currency. So in Bitcoin mining, you get 12.5 Bitcoins if you mine one single block. So that's equivalent to 87,000 US dollars. So that's a huge, healthy amount. So a lot of people in this right now, they are trying to mine blocks on Bitcoin. So it's more like gold mining, they call it, they relate it to. And this block, which has been recently mined, which was broadcasted, which was validated, this block is added in the chain, right? Hence the came the name, your blockchain. So blockchain on that, so we are simply talking about one node, right? So in that one node, this blockchain is there, and one block is having some transactions, the other block is having some transactions, the third block is having some transactions. So different blocks can have different transactions. So we are very we on the same page on that, right? So I have simply shown 2 transactions per block. However, they can vary. So a blockchain is simply a chain of blocks which are put together in one sort of in a linear manner. So you can call it as a blockchain. In Bitcoin, recently today morning I checked out, in Bitcoin currently the number of blocks are 4 lakhs 80,000 something. So around 5 lakh blocks are there in Bitcoin blockchain. The size of the Bitcoin blockchain is 136 GB. So that's not a very big size, right? 136 GB, and the number of blocks is around 5 lakh blocks. So here on the screen you can see only 3 blocks, but in a Bitcoin chain that would be like 5 lakhs in a linear manner, which are like connected to each other in a chain. So now I'm back to the definition. So we have seen this example, right? So definition of a block is, you remember that we were talking about the bank ledger, the records, we talked about the property transaction, the records, everything. So that was a record, that was a ledger, right? So one blockchain on one ledger, one blockchain on one node, it's like one ledger. So now just bear with me over here. So this is a append only distributed ledger where records are stored in a block and block forms a chain, right? The block is synchronized across all nodes. So this entire blockchain, let's say you have 100 nodes. So the one block is found. So that adds to the chain that is broadcasted on the entire network. All of them add that. So they all have the same blockchain on all the nodes throughout the network. They can validate through each other. There is no centralization of records. It's distributed ledger, which is sort of available everywhere. So in Bitcoin, there are around 12,000 to 40,000 active nodes. So their network is very big, right? So they sort of are working throughout the globe. So this value sort of varies a little bit. So some people, they run their nodes throughout the day, 24/7, 365 day a year, so do the mining. Some of the people, they sort of do the mining stuff and all that, maybe 6 hours a day, 7 hours a day, or 10 hours a day. So the number of nodes in the network, it little varies. So the varies in a blockchain in Bitcoin, that's around 12,000 to let's say 40,000. So if everyone is active, there like 40,000 nodes are there, right? So this is like one thing to keep in mind, that more the number of nodes, the bigger the network is, right? So we'll come to this back to this in a while. So we talked about everything. Okay, so we understand that blockchain is more like your chain of blocks in a network which is over let's say one node, then it is replicated through other nodes. But however, how it creates the trust, right? So it's simply some blocks are getting added to each other in a chain and they are replicated. There is decentralization, but it still doesn't create the trust, right? It's a process of how blockchain works, right? But it doesn't create the trust which is required, which is the fundamental why we were talking about that blockchain will replace the middlemen. So if this is a system, right? So this system, if you're transacting on this blockchain network, the system itself, the output of the system will create the trust. So let's check this out, that how this system creates the trust. So we are going one step inside to how the block looks like. This is still a very simplified version. I haven't put a lot of cryptography into this. So just check this out, that these are three blocks, right? So if this was Bitcoin, there were like 5 lakh of them. However, in the screen, I have only 3 of them right now. So the first block is block n. The other block is your block n plus 1. And the third is like n plus 2. It can be 1, 2, 3. It can be any 3 numbers, right? So just check this out. If you check out in the middle, you can see there's a hash value of the block, which is let's say the one which is like before this block. So if you check out the block n plus 1, you can check that the block n plus 1, it has a dependency on the block n because it contains the hash value of the block which is coming before it. So there's a dependency in every block. They point to the block which is coming before them. They have the transactions over there, and how the trust is created. Let's say in case Remember, when we do the property transaction, the person, he sort of has altered the records. Even the middleman can alter the records. Even those trusted third parties, they can alter the records. Everyone can alter the records, right? So there is no trust over there. Just check it out here. So in case some attacker tries to attack this network and wants to change the transactions which is in this block in the middle one to whatever value he wants to put some transaction. Maybe see, so if an attacker attacks, he will have couple of purposes. Maybe he wants to pay himself more money, right? So maybe he wants to do a transaction where he is getting more money out of thin air which he doesn't own, right? So this can even let's say a fraud transaction. So he wants this transaction to be in block, that okay, so in this transaction he gets all the money out of it. So what he have to do is, he will, let's say this in one node, we have three blocks in one node, right? So he will attack this node, he will hack the node, he will go to this block, and he will sort of do the proof of work. He will consume the electricity, he will consume the resources, the compute. So we are talking about how this, the person will try to hack it, right? So he will consume the electricity, he'll do the proof of work, he will do the solve the cryptographic puzzle. It will cost him real money. And then he will rewrite this block, right? The problem over here is the block which is coming next to it, like the block you can see, and on the right hand side, that also contain the hash value of the this block, right? And you remember that the data, if the data remains the same, the hash value will be the same throughout the world. It doesn't matter, it will remain the same. So in this case, the next block needs also be changed by the attacker to validate this block. So he will have to change the next block and the next block and the block which is coming before it. So in a Bitcoin network, if someone wants to attack, they will attack they will do the proof of work. They will, so one for mining one block, you require the entire electricity to solve the cryptographic puzzle, right? So the person will solve the cryptographic puzzle for all the 5 lakh blocks in that one node. And you remember, whenever one node sort of mines the block, they broadcast it over the network. So then other nodes, they validate the block and then they accept it, right? So in this case, if this attacker sort of broadcasts this node throughout the network, the other nodes will simply say, okay, this is not valid because this doesn't match the blockchain which we have. So the attacker have to at least hack the 51% of the number of nodes available, or maybe the 51% of the amount of let's say the compute power should be with the attacker itself. So in a Bitcoin blockchain, 51% is more like, let's say, the least amount of people who are online nodes are like 1200 nodes are 12,000 nodes are online all the time. So it's more like he needs to have at least around 7,000 of them to be hacked, and 5 lakh of blocks per node in everywhere needs to be hacked. So that's a very impossible task to be performed. It's far easier to just mine these blocks and earn those 87,000 US dollars to mine one block, instead of hacking sort of the entire blockchain on so many, 51% of the nodes. So this one process of immutable blockchain, that it depends, there are dependency between the blocks on the previous blocks, and the entire chain is like one single entity, right? So this distributed ledger, this distributed blockchain, this creates a trust in the system itself. So I'm just relating it to it. So in case you are trying to purchase some organic fruits or something, so what can happen is that, okay, you go to a supermarket, you purchase some organic fruits over there. So you can see that, okay, they have put in a sort of list that, okay, they are using these ingredients, the fertilizer, everything is organic, so you can trust them, right? However, it's simply written on a piece of paper, right? So in case there was a barcode or something which you can scan, and the information wasn't put on a blockchain and it was validated, so you can trust that, okay, so if the information is on the blockchain, it can be trusted because there is a dependency, everything is public, anyone can validate it, anyone can sort of check it out itself. So blockchain, the system itself, creates the trust, right? So coming back to the example which we took, so when Jack sort of transferred 10 coins to Bob from his wallet, from like in a normal bank transaction also, from his wallet, 10 coins are sort of deducted, and 10 of them is like on the is like happens get credited on the Bob's wallet, right? So a simple transaction. So this transaction we understood. In a bank we all know how it works. So in a blockchain we also now understand how it works. Everything is a blockchain is made, and the chain is synchronized, so that is a distributed ledger which is running throughout the network, and the system itself creates the trust. So this is how you can sort of replace the middlemen, and you can the system. There is no need for any trusted party. So you remember we talked about so much of hype that even Gartner report, this says that this is one of the most talked about technology these days, top 3 or top 4, right? So that hype is very real because the system itself is quite sort of robust in a sense that it provides you the trust, and it can replace the institutes, it can replace the banks, it can replace a lot of things which we have in place, right? So just to let you know that different banks, they have started adopting blockchain themselves. So before this revolution comes, they can say that we are already using blockchain, right? So you can trust us. So the world is moving forward. They are already sort of adopting this, and there's 3 type of blockchains, right? So basically, they're the most popular 3 type of blockchain. First is your public blockchain, which we just talked about. So in a public blockchain, all the nodes, they are owned by anyone, right? Anyone can own any node. Excuse me, guys. So anyone can own any node. They can send the transaction. They just need to have the wallet. They can make their accounts over there. Anyone can read, anyone can write, they can validate it, right? So everything works fine. And 2 examples of this is, like, one is Bitcoin, which we already know of, and one more example is there. It's called as Ethereum. So that's another blockchain, right? So different implementations of blockchains are there. So this is called as a public blockchain. You will check one more thing, that Ethereum is more like private blockchain also. Ethereum provides both the functionality, that you can also have a public blockchain of Ethereum, or if you want to, if you do not trust, if you do not want to implement, let's say, a public blockchain, you don't want to use the shared resources, you want to make your own private blockchain, which is managed by you, which is managed by your private organization, then you can also have these private blockchain in place. So one of the example of that is Ethereum. Even Azure platform, Microsoft Azure, which is a cloud provided by Microsoft, right? So that also provides Ethereum. You can sort of make virtual machines over there. You can Ethereum blockchain as a service is already available. So even the giants in the market right now, all the bigger MNCs, they have seen it. They have seen the entire movement. So they have already started covering the entire market and making them more relevant before anyone else can capture this market. So one more implementation of blockchain is that in case you are thinking of having a distributed database, right? So maybe you have there's a requirement that your application needs to, that your application is working on a global label, and that is over a distributed database. So instead of having that distributed database and maintaining the database, checking out the writes on every database, making sure that that everything is in synchronization, everything is like there is no mismatch in the transactions. So you can also implement a blockchain and make your application talk to the blockchain, right? So whatever transactions you are doing, whatever communication you're having, that can be put on a blockchain. So in cases having a private blockchain, it can even replace having a distributed database, because here by default the system itself will make sure that there is no double spending, the transaction is safe and secure, it's done only once, and so everything is taken care of. So even a lot of companies just to replace the distributed blockchain, distributed databases, which need to be maintained, which need to be checked out, they need to be seen how they are synchronizing with each other or not, what's the synchronization status, right? So they can also implement blockchain. When you have a private blockchain, that's a little faster than having a public blockchain, because your resources are yours, the nodes are owned by you, so you have to sort of keep sure that there are enough nodes in the entire system, they are decentralized, so that's up to you. So however, when the blockchain, when it came out in 2008, it was mainly a public blockchain. So Bitcoin came out the first. The blockchain is the underlying technology over Bitcoin. So now the people, they have seen this potential, so they have made the private blockchain out of it, and as well as a consortium blockchain. So consortium blockchain, all the banks, they literally came together and they make these 3 type of consortiums: R3, B3I, EWF. You can check them out. So these consortium blockchains are also created. So now the nodes are sort of uh, managed by, sort of owned by a group of organizations, instead of having owned by public, instead of being owned by one organization. So this is also in the same picture, right? So you have public blockchain, private blockchain, you have consortium blockchain, and people are coming up with hybrid blockchain as well. So like you can have your databases and blockchain together. So a lot of different potential is there. A lot of entrepreneurs, they have started, have seen this potential, and there I have only listed three startups over here. It's like 3 services available there, and there are hundreds and hundreds and hundreds of services, and these all are running over the blockchain market, this network. And you can think of any use case, right? So if you check out Civic, what they are doing is they are putting the identity management solution over a blockchain, right? So identity is being managed over there. If you check out the unique ID, you can see that they provide digital keys and security via blockchain for physical world of IoT devices. So whatever your use case is, if that has, if you are securely trying to transfer some funds from one place to another, if you're trying to put some digital keys, some identities, or maybe one more example can be in case you are an artist, right? So you make some digital art or maybe some sort of painting. So in case everything was let's say normally, just forget about blockchain for a point in time. So in case you are an artist, you want to sell your art. So you make it on a canvas, right? And you sell the canvas. So the whoever purchases that canvas, he knows that that is a single one copy. However, if anything is like digital, a document is in a digital form. So the person might have, and you have purchased a document from that person, right? So he might have simply copied it and have sent you that the copy of the document. There is no surety that the document is now the only single copy in the world, right? So this can happen. So if the digital documents and everything is transferred over a blockchain, you can trust the blockchain that that is a single copy. And if there's written that that is owned by you, that's more than itself to validate that that's a single copy, it's owned by you, you are the owner of it. So you can trust the entire network. So this is one more use case I have simply just from my top of my mind, I have simply put it here. So you can also have different voting websites. So if you are looking forward for some votes, maybe government can use solutions on blockchain. And even if you're looking for some market feedback, then also is possible of on having a blockchain, right? So all the votes and everything is coming from is getting on the blockchain. No one can change it, because if it is written on blockchain, it cannot be changed. There is a new program in India. It's called as midday meals. So what they do is earlier there was a government hierarchy. So the problem with that was that the funds were made available to for the let's say the poor classes, and for them to have some meals, right? So people, due to corruption, the funds never reached the right place. The quality of the meal was very bad. And when the feedback was used to give to the different organization, different layers in government, so even the feedback was sort of changed. So now India came up with a very good initiative of having this blockchain implementation. It's called as midday meals, million day meals. So in this, what happens that whenever the person gets this, the owner of this, let's say you have the meal, right? And it was a very bad quality. There is an app, you simply go there, you simply give your feedback that goes on a blockchain. No one can change it because it's already gone on a blockchain. And anyone can log in, anyone can check out that what's the quality of the meal at the point in time on that point in day. And if some authority has sort of messed around with the funds, then they will be caught. So this is one more example which is already being implemented. So the world is already moving on blockchain, and I have simply listed a couple of more industries over here. However, there are like say hundreds of industries which will be affected by it. You can make your own custom solutions. It's a huge potential right now. If you're an entrepreneur, simply go for it. So cybersecurity, healthcare, insurance, voting, crowdfunding, charity, music industry, ride sharing, you can make your different solutions over there. Public records, simply gun tracking, right? So who owns the gun, everything is like on a blockchain, so everyone can check out the number of guns over there. So everything is listed in one location. And if it's a public blockchain, anyone can simply read it as well. So they can verify. There's like everything is made public. Wills, inheritance, if it is written in the blockchain, it cannot be changed. So you can be trusted in this. You can believe the output of the system that creates the trust. So blockchain is a revolution. It is currently in an emerging state. So a lot of new things are new, and you have to sort of understand that it is this revolution is coming, and this revolution will be as big as the internet itself. And how the mainframe came and everything, the cloud came, then now the blockchain is coming. So everything came in a sequence. So whenever there's a requirement in the society, wherever there's a gap, a technology emerges and fills that gap up. So the blockchain is currently emerging right now and will replace the middlemen and all that. So I think you get the entire picture that this revolution is more like coming, right? So CloudThat have already taken the initiative of being the one of the very in the starting itself, that we have launched the fundamental course on blockchain. So in case you are looking forward for some going in further courses, right? So fundamental of blockchain level 1 is already introduced by CloudThat. So we have our office in Bangalore. In case you want to join us, you can join us here. We will, in the future, this course will be used for having different courses, level 2, level 3, level 5, right? So they all will have be in a hierarchy and will be based on one and each other, and will be very complex in the let's say in their making. So I'll ask Meherzar, my colleague over here, to explain you a little more about the course which we are offering and what's the benefit if you sort of register for it, right? So Meherzar, the floor is yours. Simply just go ahead.
Yeah, thank you, Shivam, for that wonderful session. So as Shivam told you, we've brought out a course that is Fundamentals of Blockchain Level 1, right? Now, we all know that blockchain technology is one of the most discussed topics in the business world today, especially in the financial sector. So the main purpose of bringing up this course is to understand the basics of blockchain, to gain the knowledge of blockchain architecture, tools, and practices, and to understand how blockchain is going to impact the industry. Now, we've brought out this course on, we've decided to schedule this course on the 25th of November. And it is a one-day course. And I would like to let you all know that as a token of our appreciation, we've decided to offer a 10% cashback on the training fees of the Fundamentals of Blockchain Level 1, the course that we're offering, to all the attendees of this webinar today, provided you register before 2 p.m. on 9th of November, which is tomorrow. So I would request all of you all to please fill in the feedback form, which we'll send right away. Yeah. And let's now start the Q&A session.
Right, great. So on 25th November, we are having this course. So feel free to join me there. And we'll further, let's say, go into inside blockchain. We'll check out cryptography. We'll check out how everything works. And let me check out the questions which you have. So in case you have any questions, simply ask. You can feel free to ask your questions right now. So I will be addressing your questions. It's a Q&A. The floor is open. So yeah, the server needs to be active. So Pani has asked that the servers need to be active on a blockchain network. Yeah, so it is required that these nodes will be active for the network to run. So in case there are lots and lots of nodes, the network, as big as the network is, it's far more secure than a smaller network, because you remember the attacker will be able to attack, will be able to hijack the nodes if the network is small. So public blockchain are the most secure. If it's a private blockchain, then the organizations themselves need to make sure that they need to put in additional security, let's say, measurements to be able to secure the networks, just how we do in the normal databases, normal IT, making some DMZ zones and everything, right? So then they need to take care of it. So, and you can definitely go ahead and introduce cryptography and secure the data on transit, data on rest, and everything is possible, right? So more the number of nodes, better. If it's private, then also it's sort of works in that manner. Okay, so Prashad is asking that if the prices are changing, I want to invest. So yeah, definitely a Bitcoin is a very good investment. As we have already mentioned that in the starting, the Bitcoins, they costed like $1 only, right? And now they're costing around 7,000 US dollars. That's a very healthy amount. So in case you're looking forward, so in investment, it's good. However, I won't be able to advise you on investments. Definitely, if the price goes down, if you feel free, you can simply sort of put the investment, or you can start the mining process, right? You can use your laptops, your resources to start the mining process, and maybe you will be able to. So there is one thing called as pool mining. So if you do not have the resources yourself, right? So you can pool your resources together. You can join a pool, and then you get if the pool is able to mine one Bitcoin, then you get a percentage of that yourself. So that's also possible. So that's a very good way to start. So in case you have any other questions, feel free to ask. And so, okay, so can blockchain be applied on only specific parts of a video feed, make it authenticated rather than fake news? The fake news, I won't be able to comment on that. However, yes, definitely, if that can be thought of, that how you can make the entire news more authenticated, that's possible. That's possible. Okay, so if any node hacked by the hacker, how it is validated by the nodes, how the hacked nodes will be reconstructed. So that's by default, the node will simply sort of re-download the blockchain, which is correct, the valid blockchain, the longest blockchain from the other node, whichever it is talking to, and will make a consensus. And there is a majority voting, right? So it will sort of re-download that. Any specific parts? Prashad is asking, I can be applied to complete videos. I couldn't get the question. If you can reiterate the question. So yeah, so this training video will be shared. So whoever has registered and you haven't showed up, right? So everyone will be getting the copy of the video. And however, the one who will fill up this link, and in this case, they are looking forward to having any course with CloudThat, you will get a discount. So that is like if you go through this link, fill up this link, the feedback link which we have shared. So in case we'll share the feedback link again with you. So tell us more about the feedback. So in case that's very helpful, right? So yeah, you can have, see, so E3M, they also provide, are there any tools to begin implementing testing blockchain, right? So E3M provides you with these test environments. You can go and have a look at that. So you can make your own application, D applications. So these distributed applications, they talk to the blockchain. So we are going a little bit in depth, right? So if you feel free to join me for further levels. So we have like smart contracts, cryptography, distributed applications, how they all talk, how the session is broke and everything. So yeah, you can also test out your own blockchain recordings. Initial 50, okay. So yeah, so link of this video will be given to you. So in case you have missed out on any part of the video, right? So the link will be provided. You can feel free to have a look at that. And in case you have any questions, you can simply write, you can drop a mail to sales@cloudthat.in. So that is the email address from which we have sort of send you this, the entire, the link for joining this session, right? So you can also drop a mail there. Yeah, definitely, Prashad. So that's also possible. So yeah, we will be sharing the video. Okay, so sales executive will get in touch with you in case you have any sort of question related to the courses, any question related to the cost of the courses. Feel free, our sales executive will get in touch with you. If you want, you can also drop a mail, and we'll definitely all your queries will be answered. And yeah, so this course is 1 day course. It's a level 1 course. So see, your learning has to be sort of progressive, right? So we have broken down the entire complex cryptography and entire blockchain into different levels. So the first level is a 1 day course. There will be level 2 as well, level 3, level 4, level 5 in the future, right? So currently with this course, we are taking the first step, and this will be a level 1 course to get everyone started, because there's a new technology. And the base need to be created. So that's a very good way to start a level 1 course. Yeah. So yeah. So can you? So Rakesh is answering how miners validate other mining outputs as valids. So yeah. So if you want to go into depth in this, it's called as none created. When you get that the output of this, when the proof of work is done, everything is validated. See, and one thing you need to know, we talked about the hashing, right? So the data goes into the hash function, and the hash target value is created, right? So it's very difficult to sort of, let's say, reverse this process. However, it's very easy. In case you have a thing called as nonce with you, you can check out that if the person has done the entire process or not. So it's possible. So you can different miners, they can validate each other's nodes, and that will go in far in cryptography. So the entire thing will be there. So yeah, it's a 1 day course. It's of 8 hours, and it's simply a starting course. We'll have more courses after that. So in case you have any questions, feel free to ask. So it is already 2. So let me know. Great. So we are coming to the end of this session. And yeah, so this course will be offline course, right? And in future, online version of this will come as well. So in case the request will be there for online as well, so this course can be delivered online as well. However, you understand that being a classroom course is, it gives a different feel of it. So in the starting, the 25th November, that's a classroom one. In future, online one will also come. So let me know if there are any more questions. So it's already 2. Thanks, guys. Thanks for listening to me. I really appreciate it. Thanks for your time. Uh, and so here I'm gonna sort of break off, right? Okay. Thank you, everyone.